Number 19 says an unmanned aerial vehicle, a UAV, which is this thing flying up here, is equipped with cameras to monitor forest fires. The figure represents a moment in time in which that UAV at point B, that point right here, flying at an altitude, which remember altitude is a perpendicular distance, so we're talking about angle D creating a right angle with the ground here. That altitude is the height, so the distance between point B and D is given as 1,000 meters. It says it's directly above point D on the forest floor. At the moment in time, represented by the figure, the angle of depression, that's kind of a new term for us, from the UAV to the fire. So it's talking about this angle created by this flight path of the UAV and going down to the fire. So it's already marked on the figure as being 30 degrees, as it is told to us is 30 degrees. So what we need to know is this UAV is flying parallel to the ground. And so this angle would actually be congruent to this angle right here, since those are alternate interior angles created by parallel lines cut by a transversal. And so we have a 30-degree angle inside this triangle, which we know is a right triangle by that being an altitude, and that means that this angle up here has to be 60 degrees. So we have one of our special triangles that we've been learning about recently. So in part A, it says at the moment in time represented by the figure, what is the distance from the UAV to the fire? So it's asking for this distance right here. This distance is across from the right angle. So remember, that's called the hypotenuse. The side we're given is across from the 30-degree angle, which remember is called the short leg. So remember, the relationship to go from the short leg to the hypotenuse is to just multiply by 2. So that would be 2,000 meters is the distance from the UAV to the forest fire. In part B, it says what is the distance to the nearest meter, so we've got some rounding to do, from the fire to point D. So remember, that's called the long leg in this scenario. So to go from the short leg to the long leg, we know we multiply by the square root of 3. So the long leg is exactly 1,000 square roots of 3. But since it says that we want to round that to the nearest meter, you're going to put that in your calculator as 1,000 times, or just next to, the square root of 3, and then round that to the nearest whole number. So when you put it in your calculator, you're going to get 1,732.050808. But if you're rounding to the nearest whole number, you just look right next door, which is a 0, so that means to keep that 2 a 2. So that would be 1,732 meters. So answer A is the correct one. Part A answer was 2,000 meters, and part B was 1,732 meters.